So this video is going to be about end behavior of a polynomial function. And end behavior of a polynomial function basically just states what a graph will do at its ends. Not concerned about what it's going to do in the middle, but just what it's going to do at its ends. The best way to look at it is to picture two types of graphs. You have a straight line, a linear function, or you have a parabola. Either one will do. These also could be negative, so a straight line going down, or a parabola opening down. Basically, every polynomial function will follow one of these four patterns. It will either go down to the left and up to the right, or up to the left and down to the right, or as you can see in the parabolas, it will either go up both directions or down both directions. And so end behavior of a polynomial function will only look like one of those four things. And so what we're trying to do is we're trying to see if we can tell what the graph's going to do before we plug it into a calculator so that we can analyze the function prior to looking at it. The way end behavior gets set up is this as follows. F of x goes to something as x goes to negative infinity, and f of x goes to something as x goes to positive infinity. And so as x goes to negative infinity means as the graph goes to the left, and as x goes to positive infinity means as the graph goes to the right. And so what you're looking to do is see if the function or the y values right here, do they go up or down as the graph moves to the left, or up or down as the graph moves to the right. What you'll place in each blank here is either a positive or negative infinity. You'll put either positive infinity if it's going up to the left, or negative infinity if it's going down to the left, and vice versa. So let's talk about how you can actually figure out the end behavior. Our first example will be as follows. Y equals 2x cubed plus 4x squared minus 21. And so this is a polynomial function, but the two things you're looking for are the degree, and you are looking for the leading coefficient. If you can figure out the degree and the leading coefficient, then you'll be able to state the end behavior without a problem. And so the degree is the highest exponent. So the highest exponent in this problem is a 3, and so there you go. And the leading coefficient in this problem is a 2, and there's that. And so the degree is odd, and the leading coefficient is a positive number. So when you have a function that is odd, what you want to do is you want to think of a line. So think of a line that has a positive slope. Looks like this. That means that the graph of this function, y equals 2x cubed plus 4x squared minus 21, is going to go down to the left and up to the right. And so we need to write that in our end behavior notation, which is f of x goes to something as x goes to negative infinity, and then f of x goes to something as x goes to positive infinity, or to the right. And so the graph is going to go down to the left, so we're going to put negative infinity, and then the graph is going to go up to the right, so we'll put positive infinity there. Once again, this means to the left, and this means to the right. And so the y values are going down as it goes to the left, and the y values are going up as it moves to the right. Let's do an even one. So for example 2, let's use y equals negative 3x to the 4th plus 2x to the 3rd minus 15. So the degree of this polynomial is the highest exponent, and in this case it would be 4, and the leading coefficient in this problem is -3, and so we're looking for the fact that the degree is even and the leading coefficient is negative. So what I want you to think of when the degree is even is think about what a parabola does when there's a negative number in front of x squared, and so the parabola opens down. And so that means that both ends of this function, even though it's not going to look necessarily like a parabola, its ends will do the same thing that the parabola does, and they will both open down. And so you'll have f of x goes to -infinity, going down as x goes to -infinity, and f of x goes to -infinity also as x goes to the right, and that will be the end behavior for this function. So one last time, you need the degree, which is the highest exponent, and you need the leading coefficient, which is the number in front of the variable that has the highest exponent, and you want to tell if it's odd or even, and if it's negative. If it's odd, think of a line. If it's even, think of a parabola. Alright, hopefully my cat didn't bother you too much if you can hear him in the video. So, talk to you later.